Example 3, I want to find the domain of the function f of x equaling x minus 4 over x squared plus 5x plus 2. So we're going to set the denominator equal to 0. So I have x squared plus 5x plus 2 equaling 0. And then we need to solve this. So since this isn't factorable, I need to use the quadratic formula. So I have that x, hold on a second, x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times a times c all over 2a. So x is equal to negative 5 plus or minus the square root of 17 over 2. So the domain of f is the set of real numbers except negative 5 minus the square root of 17 over 2 and negative 5 plus the square root of 17 over 2. Now I want to find the domain of the function. I want to find the domain of f of x equaling x squared minus 5x plus 1 all over x squared plus 10. So I'm going to set the denominator equal to 0. So I have x squared plus 10 equaling 0, which will give me x squared equaling negative 10. And since a real number squared is non-negative, we conclude that there are no real number solutions of x squared plus 10 equaling 0. Therefore, for the function g, no values of x lead to division by 0. So the domain of g is a set of all real numbers. So in problem 1 of example 2, we found that substituting 3 into the expression 2 over x minus 3 leads to a division by 0. We call the number 3 an excluded value of the expression. So a number is an excluded value of a rational expression if substituting the number into the expression leads to a division by 0. For instance, 5 is an excluded value of the expression 7 over x minus 5. So 5 is an excluded value of this expression. This means that 5 is not in the domain of the function f of x equaling 7 over x minus 5. So for the expression 7 over x minus 5, 0 itself is not an excluded value, because if I take 7 over 0 minus 5, I end up with 7 over negative 5. And 7 over negative 5 does not contain a division by 0. So for the expression x over 3, again, 0 is not an excluded value, because I can have 0 over 3, and that does not have a division by 0. In fact, 0 over 3 is defined, and it's equal to 0.